All right, everybody, welcome to the video here for lesson number 3 on types of statistical studies. So today's lesson, we're going to go through and try and identify the 3 main types of statistical studies that we're learning in Algebra 2. So basically, what is a statistical study? So statisticians need to have a way for collecting data. There are different ways that we can collect data to determine an outcome or see relationships between variables that we're studying. So here are just a couple ways that we can do that. So the first one is called an observational study. The key word there is observe. We're going to observe something. So an example here is a study investigates whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls play a video game that they've never played before. Keywords here, randomly selected. And then it says the time it took them to reach the end of a certain level or expertise was recorded. So a couple things that we can see here from this example of an observational study. First, the sample needs to be randomly selected. By randomly selecting my sample, what that's doing is it's giving us a representative sample. What a representative sample is, it is a sample that represents the population. So for example, if I was to do this exact survey at Cornwall High School, I would need to randomly select the boys and the girls that I wanted to use for this study. So I would go through and maybe give every single boy and girl a number in the school and then randomly choose 20 boys numbers and 20 girl numbers. This would ensure that I am not stacking it up so that all the good boys that play video games I'm picking from my survey. It represents the whole sample, the whole population of what we're trying to sample here. Okay. So other things that we have to look at here. There should be no question. So in an observational study, we need to observe something. So there's no question being asked. Okay, you might say that there's a question being asked, but there's not. I am not asking are boys or girls better at video games. We're just seeing if there's a relationship between the boys' results and the girls' results here. All right, there's no question being asked. All right, an example of a question being asked, you could say I randomly selected boys and asked them what their favorite video game was. That would not be an observational study. Okay, there's no question being asked. The other thing here is someone is observing the results. So when you're reading through the example, you can usually tell that it's an observational study because they're going to describe how the results are being recorded. So here it's talking about these boys playing a video game and these girls playing a video game, and it says the time it took them to reach a certain level was recorded. Meaning there are some creepy guys sitting in the back of the room watching these kids play video games and saying, oh, boy number 1 made it through the level in 8 minutes and girl number 2 made it through the level in 7 minutes. That creepy guy in the back, that's the statistician. He's the one or she's the one observing the results. The last thing that we can say here about observational studies is there is no cause and effect. There's nothing that I'm introducing to this study that's going to cause or change the outcome. All right, certain statistical studies will have cause and effect, and you'll see those as we move through here and look at these different examples. In an observational study, we're not observing change, okay? We're just observing outcome. That's all we're really looking at here. Okay, moving right along here, let's talk about survey. All right, so let's read through our example here of a survey. A survey is actually probably the most commonly used way of collecting data, or at least the way that you would think that we're going to collect data. So it says a study is conducted to determine the number of students who do not like social studies throughout the school. As students entered the building, every 10th student was asked if they have a favorable view or an unfavorable view of social studies. let's stop right there because this is a sampling technique that produces a random sample. So if I asked every 10th student that walked into the building, I'm going to get some students that live in New Windsor, I'm going to get some students that live in Cornwall, some students that live in COH, I'm going to get different age groups, I'm going to get 9th graders, 10th graders, 11th graders, and it's going to be mixed up because I'm only choosing every 10th student. So this is going to not only be a random sample, but it's also going to be representative of the population. So it's going to be a representative sample of the population as well. All right, so that's actually a really good sampling technique. It then says the students' responses were recorded. So it says this word, asked. So surveys ask questions. The statistician is literally interfering with this person's day. They're saying, hey, can I stop you and ask you a quick question whether or not you like social studies at Cornwall Central High School? Right? So they're getting in this person's way and asking an actual question. Okay. There's also, just like the observational study, no cause and effect. Right? We're not introducing something that's going to change this person's mind by asking them that question. We're literally just saying, do you like this? Do you not like this? Would you eat this? Would you not eat this? There's a million different surveys that you can ask. Okay. You probably are more familiar with surveys only because they're easier to do. If you take a look back at your notes into the probability packet, you'll notice that some of the questions that came up in those two-way tables were surveys. Right, it said random students were asked whether or not they like country music, rap music, or whatever, rock music, and the results were shown in this two-way table. That was an example of a survey. Right, we asked somebody a question, we determined the result, and then we can look at relationships from there. Surveys and observational studies are really based on, are there relationships that we can see from the observational study, or are there relationships that we can see from this question that we asked? The next one is an experiment. Right? Experiment, that's a word we know, right? Think of science. If I'm doing an experiment, I'm testing something, right? I want to see, does this change something? And that's the same thing that happens in a statistical study. So it says, a study determines whether taking aspirin regularly helps prevent heart attacks. A large group of male physicians of comparable health were randomly assigned equally, randomly, so we have a random sample here. As soon as I see the word randomly, I kind of know that we have a random sample. So it says they randomly assign equally to take aspirin every second day or taking a placebo. For those of you that don't know the word placebo, that's basically like a sugar pill that they're giving you and telling you that it's aspirin. So it's testing whether or not taking the aspirin is actually going to make a difference, or is it a mental game? Am I physically putting something into my body every day, even though it actually is meaningless to my body, and making me think that something is happening or not, right? So it's kind of like a test group. So after several years, the proportion of the study participants who had suffered heart attacks in each group was compared. So first off, big difference here, there is cause and effect. So we've already established that we have a random sample, right, a representative sample, because we're randomly choosing people here again. But now one difference here between an experiment versus the other two is there is cause and effect. I'm introducing something and seeing if that something makes a change in the future. Okay, it doesn't have to be aspirin, it could be anything, right? It could be, I want to see if the test results on my most recent math test are increased by listening to country music while the test is being given versus not listening to the country music while the test is giving. Is that introduction of this new thing making the outcome change? All right, so we have cause and effect. We also have to have two groups. We have to have a test group, and we have to have what we call a control group. All right, so in this particular example, the test group would be the group that gets the aspirin. The control group would be the placebo. Right, so the control group is just basically saying, if I actually do nothing, will the results change? right? So if I have nothing that's being changed, so there's no cause, so we're just determining the outcome, versus the test group that has this cause, that has this change. Is there a major significant difference when I give this aspirin versus not giving the aspirin? Okay, so we have random sample here again. Everything has to be a random sample. If we're not doing a random sample, we're going to get some type of bias here. Okay. So there's our three different types of surveys. So here's what I'm going to ask you to do. So it says, for each of the following study descriptions, identify whether the study is a survey, an observational study, or an experiment. Give a reason for your answer. For observational studies, identify the population of interest. So the population of interest is, who are we trying to study, right? Are we studying teenage boys, or are we studying, women over 40, whatever our population is. For experiments, identify the treatment and response variables. So in this last experiment here, we have treatment and response variables. So what's my treatment? My treatment is taking aspirin. My response variables is whether or not I have a heart attack, right? So treatment is, what am I introducing? And my response is what's happening by me introducing or not introducing that new thing. So go ahead, try these. I'm going to pause the video. When I come back, I'll have the answers there, and I'll talk through why I chose what I chose. There are a couple that you can make the case maybe is one versus the other, but I'll explain why I'm choosing what I'm choosing, all right? But definitely take a couple minutes here and try these. If you have to look back at your notes at the three different types of observational studies here. All right, so welcome back to the video. Hopefully you paused it and actually tried this. Let's see how you did. So this first question I determined is an experiment. Here's why I'm saying it's an experiment. So the local Department of Transportation is deciding between paint A and paint B, and I want to determine which one is going to last longer. So because there's two randomly assigned groups, so they're taking two groups, they're randomly assigning the roads that are going to get that certain paint, paint A versus paint B, and we're going to see if that paint gives us a favorable outcome or not, a longer life. So there's some type of a treatment, right? The type of paint is the treatment that's going on here in your experiment. Okay. The response variable is how long it takes for that paint to dry out or to chip off. So this is an experiment because we're talking about two randomly assigned groups. One of them is getting one treatment where the other one is getting a different treatment in this case, and we're determining the outcome. There's cause and effect here, right? Does paint A cause the road paint to last longer versus paint B, etc. Okay. The next one is an observational study. It's an observational study because the only way to find out whether or not somebody's wearing a seatbelt as they're driving is to observe it. Okay, we're not going to ask people as they're driving. That's crazy. We're not going to do an experiment where we have some people wearing a seatbelt and some don't and see, what happens to them. There's no cause and effect here. It's observing something, right? You can visualize somebody standing on the roadway and with a clipboard saying that car has a seatbelt, that car does not have a seatbelt, and so forth, and observing this. The population of interest here is all drivers in the United States. It says national highway traffic, so national is talking about the whole nation, and it wants to figure out drivers in the United States. Okay, if we were to change this to the local highway traffic, and it said instead of in the state, in the United States, if it said in Cornwall, then we'd have a different population of interest. But because it says in the United States, we have our population of interest right there. The next one is a survey. I know that this is a survey because of that word that I circled right there. Ask. We are literally asking people, do you brush your teeth and for how long? Okay, it's a very simple way of seeing that it's a survey because we're asking a question. We're not determining whether or not brushing our teeth is going to cause our teeth to fall out or anything crazy like that. There's no cause and effect here. We just want to know, are you brushing your teeth or not? Right? And you should be. Okay. The next one is a ton of words. Hopefully you actually read through the whole thing here. I know it's a big paragraph. Sometimes the stats problems are a lot of words. But basically the gist of this question is this teacher wants to know if memorizing words depends on whether or not they're words or not. So she randomly selects two groups of students, gives some of them real words like fly, pen, and red, and other words like very random letters like ver, zop, and whatever those three letters make up. And she's asking those students to memorize them and see how many of them they can recall. Now, if you're reading this, you're saying there's a test group here. Okay, I'm seeing if I give these random three-letter words to students, can they memorize those the same way that they have familiar words like fly, pen, and red? So we have two groups that are randomly assigned, and we're determining whether or not there's cause and effect here. Is there a effect on whether or not I'm giving you real words or not real words? So it's an experiment because we can clearly see that there is cause and effect. Okay. Normally, when you see that two groups are being created, it's probably going to be an experiment. I don't like to say always here, but we'll say probably, right? Because that usually determines that we have a test group and we have a control group. Okay, so number two gives us three different scenarios. All right, it gives us three different scenarios. It wants us to determine which one's an experiment, which one's a survey, and which one's an observational study. So go ahead, pause the video, read through the three different scenarios, and see if you can identify which one is which and why. And actually, we'll call this scenario A, B, and C. It'll be easier for us to say it below. All right, so let's see. So scenario that describes an experiment. Hopefully you did not say scenario A. I know it seems like that sounds like an experiment. You want to see if smoking leads to birth weight defects and things like that. But if that was an experiment, you would have to actually force women who are pregnant to smoke cigarettes. That's not what they're saying there, right? They're observing something in A, but we'll get to that later. The scenario that's an experiment is scenario C. And we can say because there are two groups and there is cause and effect. So we're taking these dogs, we're randomly selecting them into two different groups. We're giving two different types of food, and we're saying which group of dogs ate more food after being food deprived overnight. So we're testing something. We have a cause and effect. We're experimenting with something, right? Was one dog food eaten more than the other dog food? That's an experiment. The scenario that describes a survey would be B. So the survey, we're asking people, it even says right there, uniformed police officers asked a random sample of 200 students about their drug use. So let's think realistically. If I was a high school student, or you who are a high school student, and you were walking down the hallway and a police officer said, "Hey, high school student, do you smoke marijuana or do you do illegal drugs?" Even if you did, I would say you'd probably tell that police officer no. So these results are going to be biased because the questioner was a police officer. If the questioner was not a police officer, if this was asked in a different way, maybe by one of your peers who'd feel more comfortable saying yes or no to whether or not you did drugs, or if it was a blind sample where you can give your response without anybody knowing who you are, all of those different things might lead to that survey being a little bit less biased. But this survey is definitely not going to have accurate results because of who is asking the question. Leaving the remaining study, and that is going to be an observational study. So it is possible to perform an experiment to determine if there's a causal relationship. Causal relationship is just saying, is there a cause and effect? Okay, and the answer to that is no. How could I change example A into being an experiment? I would have to force women to smoke before they gave birth to their baby. I don't want to do that, right? I don't care if you're, a scientist or not. We don't want to force women to do something like that. So we'll say no, because an experiment would force a random selected group to smoke. So how we would change that into an experiment, we'd have to say, I have 100 pregnant women. I'm going to randomly select 50 of them and say, you have to smoke cigarettes while you're pregnant. That's not going to happen, right? So we can't make that an experiment. We can only look at that scenario as a observational study. Number 3 says, a researcher wants to find out whether high levels of a certain drug given to an experimental rat would decrease the time it took to complete a given maze to find food. Why would the researcher have to carry out an experiment rather than an observational study? So here's one reason. Mice, or rats in this case, don't just take drugs all on their own. They'd have to be given drugs. So we'd have to say rats do not take drugs on their own. The drug would have to be given to them. So to make this an observational study, you'd have to say, I want to sit down and observe the rats and seeing how fast they get to the end of this maze and saying, oh, hey, look, rat A took drugs beforehand and rat B did not take the drug beforehand. Well, I don't know who's taking drugs or not without giving them drugs because they're rats, right? If it was people, it would be different. Right? If it was people, you could say, that person was, is choosing to take drugs before this survey or this study, and these people are not choosing to take drugs before this study. Rats don't have that choice. They have to be given the drugs, okay? So then it says, describe an experiment the researcher might carry out based on 30 comparable rats on the 3 doses, 0, 1, and 2. So we'd have to randomly select 3 groups of 10 rats. So we're randomly assigning these rats to 3 different groups, each group having the same number of rats, okay? Each group will be given 0, 1, or 2 milligrams of the drug. And then all 30 rats will complete the maze, and times will be recorded. So to make this a good experiment, we are taking the 30 rats, we're randomly assigning them to 3 different groups. So we're going to number our rats like 1 through 30, and then randomly select 10 numbers and put them in group 1, randomly select 10 more numbers, put them in group 2, and then the remaining 10 would be in group 3. So in each one of those groups, I'm going to give them a different dosage of this drug. So in one group, I'm going to have 0, that would be the control group. And then I have 2 test groups. I have the test group with 1 milligram and the test group with 2 milligrams to see if these times are going to change. So then all 30 rats are going to complete the maze, and our times are recorded. I then can look for cause and effect. So I can look and see, were the results of the test group different than the results of the control group? Okay. Were the 2 test groups even different, right? 1 milligram versus 2 milligrams. If I give a higher dose, does it make the rat go through the maze faster or slower, etc.? So there's a lot of things that we could determine from the results. Right now, we're just talking about how we can find those results. Hopefully this video helped. I know I did a lot of talking in this video. Notice not a lot of actual numbers and math. It's more of just knowing what we're talking about when we say things so that we could start to really dive a little bit deeper into statistics here in the next few lessons. Hopefully I see you soon.